Bismillah ar-Rahman ar-Rahim. Assalamu alaikum and greetings to everyone. I am Muhammad Alkhair Arif, a final year mechanical engineering student. When I was a kid, my parents used to buy me a lot of toys. Yes, I was a spoiled kid. I would play with them the whole day, and when my parents come the next morning, they would see them disassembled into hundreds of tiny pieces. It was because I was that curious type of kid who wants to know everything about these toys, like what is the concept, how do they work, and where are these sounds coming from. I was a funny kid. At that time, I used to live near the airport, where most of the aircraft taking off and landing, they crossed by my house. And no matter how repetitive this was, but whenever I hear an aeroplane approaching, I would take my head out of the window and try to spot what aircraft is that, what size is it, and what airline is that. I fall in love with these machines since my childhood. And I still remember the first day when I hopped into an aircraft. I was amazed by the size of it, and I was mesmerized by the cool up and down motion of the wing parts. Then that curious mind thought, Alkhair, one day we will disassemble an aircraft. Speaking of air travel, it had tremendously changed how humans live and travel. It had connected people from different backgrounds, heritage, countries. Now, with air transport, every single human can travel from point A to point B, no matter how far it was, in less than 24 hours, of course, within our planet Earth. Indeed, the world had become a very tiny village after the invention of commercial aircrafts. As early stages of development, air transport was not affordable, as the cost to travel a single kilometer is equivalent of traveling a 50 kilometers in today's measurements. The graph on your right shows the global air traffic revenue for airliners from 1979 all the way to 2014. The trend is observed to be increasing as a result of the continuous development efforts on aircraft technologies that aims to reduce the operational cost, therefore reducing the airfare ticket prices, making airplanes and air travel affordable to much more people. With the continuous development of these technologies, the number of air travelers, as shown in the graph on your right hand, had constantly kept on increasing year by year, which generates tremendous amount of revenue for airline and aircraft manufacturers. Due to the increase in the demand, in the past decades, aircraft manufacturers had witnessed a huge number of aircraft orderings from different varieties, from small, medium, and even the jumbo jets. With the continuous increase in aircraft numbers in the skies, as illustrated in figure B, waste from their engines harm our environment, which causes pollution. But engineers and scientists did not cross hands and watched. In fact, their efforts did not stop since the development of aircrafts to reduce their impact on the environment. As for today, figure A is not so relevant, as most new aircraft do not eject as much smoke as you can see in figure A. Thanks to the engineers and scientists, as their achievements had successfully reduced the negative environmental impact caused by aircraft. However, did you know there are other interesting ways where impact of aircraft environment can be mitigated aside from engines? Well, we will explore these ways through the presentation. Therefore, lend me your attention and let's dig in. Despite the pandemic and its negative impact on the air transport business, the International Air Transport Association had published a statistical estimate that air travel industry is going to increase rapidly, where the number of air travelers 1 year after the recovery from the pandemic is going to surpass the highest peak achieved in 2019. Therefore, we need to utilize the time to improve our air travel mean, which are aircrafts. Then, how this research aim to optimize the performance of aircrafts? Well, we will be focusing on altering the shape of the aircraft wing to generate more lift at the same angle of attack. The wing will be able to take off with less power comparing to the conventional wing. Less use of power reflects in less fuel burned. Moreover, reduction in fuel burn save fuel. Saving the fuel will have a direct impact on the cost. Therefore, airfare tickets are going to be reduced. And most importantly, the aircrafts are going to be more environmental friendly. And last but not least, we are introducing a new mechanism to aircrafts that was not possible before. But before we dig in more into the topic, let me ask you a question. Which part of the airplane lifts it from the ground? Is it the engine? Yes, it's the engine. What about the wing? Yep. Basically, the engine and the wing work together in order to lift the aeroplane. The engine provides the force and the velocity that drives the airplane forward. The wing creates a variation of pressure between the top of the wing and the bottom of the wing. The variation of pressure causes the aeroplane to fly. To reduce the pollution, we definitely need to use less power. Therefore, high efficiency and more environmental friendly engines are required. But also, we need the aerodynamic enhancement on the body of aircrafts, which also plays an important role to achieve the aircraft enhancement goals in terms of efficiency and environmental impact. In this research, a simple airfoil was constructed with few enhancements. We added a suction area, as you can see, in the trailing edge of the airfoil, which is the front part, and then we added a blowing area at the back of the airfoil. The suction areas draws air into the airfoil, which is the wing, and then the air is then blown at the back of the airfoil, referred to with the orange arrow. We believe those minor changes in the aircraft would enhance and optimize the flying characteristics based on the research published. SolidWorks was utilized to model a small aircraft, which is basically a replica of the Cessna 172, and we fitted the wing with the new proposed geometries. The necessary flow simulation equation, like the Navier-Stokes equation, the kinetic turbulent model, etc., along with the boundary conditions and the fluid properties of air, were written in a flow simulation software called ANSYS Fluent. Then the simulation was run for 24 hours. Later, we got the results. The simulation contour results had clearly illustrated that suction and blowing have direct impact on the flow characteristics of air around the wing. The figure shows the difference when suction geometry is opened and air is allowed to enter, and when it is closed and air is allowed to flow like a normal wing. When the suction geometry is opened, a kind of turbulence is generated at the leading edge of the airfoil. This turbulence at this front of the airfoil causes the aeroplane to slow down at a rapid pace. Comparing to the no suction zone, you can see a green area at the leading edge, which emphasizes that there is a relatively low amount of turbulence in the front. The graph visualizes the change in drag coefficient, which is the coefficient that slows down aircraft by using the drag force, which is a force that opposes the forward motion of the aircraft. When at the conventional wing, represented by the blue line, at the highest angle of attack of 16, the drag coefficient is seen to be 0.1, where when the suction geometry is opened, the drag coefficient increases all the way to 0.15. This increase in the drag coefficients provides the aeroplane with the new proposed mechanism, which is air braking. But then you can tell me that, wait, Alkhair, aeroplanes have brakes. Well, yes, you are right, they have brakes, which are called spoilers, but then they are only usable when the aeroplane is on the ground, as using spoilers on mid-air will cause stalling of the aircraft, which is the sudden changes of the pressure around the wing, which causes the airplane to nosedive or fall off the sky, which will cause a catastrophic results. On the other hand, the blowing geometry had an effect on the pressure below the wings. The figure of the wing with blowing and suction geometry had recorded a pressure at the bottom of 34.9 comparing to 34.1 for the conventional wing. This variation of pressure, which is recorded to be higher at the new proposed wing, the introduction of the blowing geometry on the wing had resulted in an increase on the lift coefficient, which is responsible of lifting the aircraft to the sky with minimum power. The graph shows the conventional wing lift coefficient, which is recorded to be 1.18, and then after the introduction of the blowing geometry, the lift coefficient had increased all the way to 1.6. This increment in the lift coefficient had increased the payload of the aircraft by 9.8%. Not only that, but it has also reduced the fuel consumption by 7.5%. The health of our sons and daughters lies between our hands. Damaging the environment is indirectly killing our next generations. It is our responsibility to facilitate the newer generations with clean and healthy environment in order for them to achieve their life goals. We should strive to reduce pollution as much as possible, as we cannot compensate our health with wealth. Ladies and gentlemen, we are from different backgrounds, engineers, scientists, lecturers, etc. But if there is a take from this presentation, I hope despite our diverse professional backgrounds, we all can contribute to keep our planet Earth green and clean in our own ways. With that, I end my presentation and thank you very much.